Are you sure?
Okay, everybody. As we start the next operation here, we're going to be looking at something known as conic sections. And the reason we do that, talk about that, is something like this, where we have a cone, which, by the way, this is the cone. Okay?
The whole thing?
Yeah.
Oh, it looks good with the light going through it.
Now, and the cone is going to be sliced by planes at different angles, creating different shapes. Here's one area where the plane intersects, and the intersection is a particular shape. We'll talk about it in just a minute. Some of these shapes you know quite well, and some of them maybe not so much. So as we go through our conic sections, we want to be able to figure out what are they. So we're going to list down some of these things. And here's a partial example of one. If I slice the cone this way, what shape am I getting?
Circle. Square.
So one of our conic sections is the circle. Now, if you look closely at this one, you'll notice that there's a green one here that's pretty much straight up and down, and then there's this other one that is at an angle. So right there. You might know what that shape would be?
Parabola.
It is the parabola. And the parabola is the one that comes in at an angle to the base of the cone. It's another conic section. And then there's this yellowish colored one in here. Anybody see what that is?
Ellipse.
And you'll notice that it is at an angle also, but unlike the parabola, the angle is such that it comes on either side of the cone and not just up to the bottom of the cone. And this one's called the ellipse. The fourth one, and this is the one that we're going to, or the fourth of the ones that we're going to deal with, is on this one. And it is the intersection of these two parts right here. Anybody know what those two pieces might be?
Parabolas.
Close.
Hyperbole.
They're hyperbolas, not hyperbole, which is an English thing.
Extreme exaggeration. Hyperbole.
Hyperbola. And what you'll notice about this one is the plane is perpendicular to the base of your cone, and that plane intersects twice, so you end up with these two pieces that is the hyperbola. There's some other conic sections that we're not going to spend time on because we spent a lot of time on them in the past, such as if this plane comes in and touches, say, this front edge right here, and touches this edge right here.
It's a line.
It is a line.
Yeah.
If, on the other hand, the plane that you're seeing here gets pushed to the point that it lines up right here with this center line of the cone, and right here on this side of the cone, what kind of shape is that going to create?
Two.
Well, you're getting closer. Two intersecting lines. Again, that's something you guys have looked at in the past. You've seen a lot of things about intersecting lines, also a lot of things about lines. There's one more that we have that we're going to be looking at or talking about briefly, and that is, instead of slicing this way with our circle like we have here, our slices keep coming closer and closer and closer until we get right here.
Is that a point?
That is a point.
Whoa, that's awesome. You took it out.
So that's our last conic section. So what we're going to be doing with this stuff is we're going to be looking at how do we describe them, how are they drawn, what's their definition, those kinds of things. Some of you last year in Algebra 2 might have spent some time doing something with string and pins and hot glue and creating some of these shapes. How many of you were doing that last year?
That was awesome.
Okay, that's a lot of you and not everybody.
Are we going to do spirograph?
We are not going to do those things in here. Most of you have already done them, so you guys can go down the hallway and look at Algebra 2. Right now, some of them are starting to do it already again. Talk to people in Algebra 2 and see what's going on if you don't remember. We're going to actually try to do some of the background mathematics and talk about what are the equations, what information is related to these things. Today, we're going to focus our attention on both the circle and the parabola. You've had some background in both of those already. The parabola we're going to look at is different than what we looked at in first semester. First semester was purely from the concept of a function nature and a squared function. Now we're going to focus on it in a little different definition format, but it's still going to be a parabola. The circle, you might have touched on in geometry class a couple years ago. Hard to say. Then when we come back next week, we're going to talk about the ellipse and then finally the hyperbola, and that'll be what we do and cover in this particular chapter. The rest of them are rather simplistic cases, and so we don't spend much time with them. One thing you want to know, maybe you don't want to know, but one thing you're going to know is what's known as a general equation. Of conic sections. Let's see, something like this. Sorry, not little a. Capital A x squared plus capital B y squared plus capital C x plus capital D y plus E equals 0. A, B, C, D, and E are all numerical values, some of which might be 0. It's possible if A squared or A and B were both 0, then you have the equation of what value? In that line?
Is that a circle or a 0?
That's a 0. If the A and B were 0, then you just have the line equation, right?
Yes.
So, depending on what we're dealing with, depends on what equation we end up with. If, on the other hand, we have one of these values being squared, do we remember what happens with one of our values being squared? What shape that might make? That is a parabola. So we're going to eventually get there. Questions so far? Okay, so let's look at the circle first, and then we'll come back and look at the parabola. How would you define a circle?
Constant radius all around.
Okay.
Not given a set start and end point.
So no start and end, constant radius distance from
The center point.
center point. Okay. Well, one way we can describe this is the locus of points which are equidistant from a fixed point. Now, anything in there that you're going, what is that? The word locus is a way of saying collection of points that meet this requirement. So we want the collection of x and y values that meet the requirement that they are equidistant from some fixed point. Would that describe for you a circle? Maybe not the way you use the definition, but would that be a circle then? I hope so. So this is what we're going to look at. And the concept in here is this idea of equidistant from a fixed point. And so when we get ourselves working down here, we end up with an equation that looks like this. When we get all said and done, we form a circle in this format. X minus h squared plus y minus k squared equals r squared, where h comma k is the center. And what about that r squared number? And r is equal to the radius. Questions? Okay. Then we're going to look at here in a minute an example of how we utilize this information.